Hi, everyone. In this lecture, we're going to be talking about concentrations. So concentration refers to the amount of solute divided by the amount of solvent. So how many particles are in your solution? And we have four different ways of expressing concentration that we're going to be looking at today. We can express concentration in terms of mass percentage, volume percentage, mass to volume percentage, and molarity. So let's start with mass percent. So mass percentage, as the name implies, is the percent of solute in your solution expressed in units of mass, grams. And so mass percentage is grams of solute per 100 grams of solution. Now, this one's a little tricky because we're talking about grams of solution, which is the solute plus the solvent. So we'll talk a little bit more about that nuance here. If we had, let's say, 8 grams of potassium chloride, and we add water until the total mass is 50 grams, then we can express that as a mass percentage. So mass percent equals grams of solute divided by grams of solution times 100. And so you have 8 grams of KCl in 50 grams of solution times 100. That will give you 16% KCl. Let's do another practice problem. A solution is prepared by mixing 15 grams of sodium carbonate and 235 grams of water. Calculate the mass percentage of the solution. So the percent M over M, this is a abbreviation for mass percentage, mass over mass. So percent M over M is going to be equal to grams of solute divided by grams of solution times 100. Well, we have 15 grams of Na2CO3. Now the solution is the total mass. And so that would be 15 grams plus 235 grams, which is 15 over 250. And I need a calculator for that. I get 0.06. And then the times 100 is 6% Na2CO3. So just remember the solution mass is the total mass. So solute and solvent. And it looks like we did it right. So let's talk about volume percentage. So volume percent is abbreviated percent V over V. And we typically use this when our solute and our solvent are both liquids. So like if you're dissolving alcohol in water, it would be a volume to volume percentage because they're both liquid. And so volume percentage is defined as milliliters of solute per milliliter of solution times 100. Now, you can also have a mass to volume percentage, and this is abbreviated percent M over V. And we would use this in a situation where our solute is a solid and our solvent is a liquid. So like if I'm dissolving sugar in water, I would probably express that as a mass to volume percentage, grams of sugar per milliliter of water. So it's expressed as grams of solute per milliliter of solution times 100. All right, let's do a study check. Write 2 conversion factors for each solution. So they give you the percentage and they want you to express it as a fraction. So 8.50% M over M NaOH. Well, percent means per 100. So this is going to be 8.5 per 100. The M stands for mass, and the unit of mass is grams. So we know we're talking about grams over grams. And this is going to be grams of NaOH per 100 grams of solution. And anytime you're expressing a fraction, you can put it whichever way you want. And so the other way to express this would be 100 grams of solution per 8.5 grams sodium hydroxide. Let's do the next one. 5.75% V over V. Well, percent means over 100. So this is going to be 5.75 over 100. The V stands for volume. And so the unit of volume is milliliter. And so this is going to be milliliter over milliliter. And we are talking about ethanol. And so that's our solute. And on the bottom, you're going to have solution. And you could express that the other way around. You could say that there's 100 milliliters of solution for every 5.75 milliliters of ethanol. Let's do the third one here. 4.8% M over V HCl. So percent, we know it's 4.8 over 100. M is mass, V is volume. The unit of mass is grams. So this is 4.8 grams. V is volume, the unit is milliliter. And we're talking about HCl. And solution goes on the bottom. So there's 4.8 grams of HCl per 100 milliliters of solution. And you can express that the other way around. You can say there's 100 milliliters of solution for every 4.8 grams of HCl. Okay. So be able to express a percentage as a fraction, because you're going to have to be able to do this when you're solving word problems later on. Now, the last way we express concentration is molarity. Molarity is abbreviated with a capital M. It means the same thing. And it is moles per liter. Molarity, mole per liter. And so it's moles of solute per liter of solution. You have to have that memorized. And so if we had a 1.0 M solution of NaCl, this is telling us that there is 1 mole of NaCl for every 1 liter of solution. This capital M right here, you see capital M next to a number, that means moles per liter. Let's do a practice problem with that. What is the molarity of 0.5 liters of sodium hydroxide if it contains 6 grams of sodium hydroxide? And so they're asking us about molarity. And once again, we know molarity means moles per liter. Well, they gave us liters, but they didn't give us any moles. They gave us grams. So we have to convert grams to moles. So we need the molecular weight of sodium hydroxide. So let's check the periodic table. And we can see that sodium here is, we'll call it 23 grams per mole. Oxygen is 16 grams per mole. And hydrogen, we'll just say it's 1 gram per mole. I'm rounding to make this fast and easy. On the exam, use all the decimals. So sodium, we said was 23. Oxygen was 16. Hydrogen was 1. So NaOH. If you add those together, should get 40 grams per mole. Okay. Now that we know the molar mass of this, we can convert the grams into moles. So 6 grams of NaOH times 1 mole for every 40 grams. So 6 divided by 40, grams cancels. I get 0.15 moles of NaOH. Now to get molarity, we need moles per liter. So take this number here, 0.15 moles. We're going to divide it by the 0.500 liters that was given in the problem. And we should get 0.3 moles per liter, or capital M for molarity. And it looks like we did it right. Let's do another one. What is the molarity of 0.225 liters of KNO3 if it contains 34.8 grams of KNO3? Well, we're going to have to convert grams to moles because molarity, you know, is moles per liter. They gave us liters, but they didn't give us moles. They gave us grams. So back to the periodic table. Looks like K, we'll call that 39 grams per mole. Nitrogen is 14 and oxygen is 16. So K is 39, N is 14, oxygen is 16, but there's 3 oxygens. And so KNO3 should have a mass of about 101 grams per mole. So let's start with the given value here, 34.8 grams KNO3. And there is 1 mole for every 101 grams. Grams cancels. So 34.8 divided by 101. I get 0.34455, and it keeps going. And so we're going to take that value that we just got there, 0.34455 moles. We're going to divide it by the number of liters, 0.225 liters. And I get something like 1.53 molar KNO3. Looks like we did it right. So whenever you're given a molarity, it's going to be expressed like this. They're going to give you some number and then a capital M. Now remember that capital M stands for molarity, which is moles per liter. And so you can think of this as 3.5 moles of HCl for every 1 liter of solution. or 1 liter of solution for every 3.5 moles. So if you see it written like this, you need to be able to express it as a fraction. And you can express it this way or that way, depending on the situation that you need. But be able to convert this to a fraction. If you see the capital M, it means moles per liter. So this chart is just giving some examples of how to turn concentrations into conversion factors. So if you see a percentage with M over M, that means grams. So 10% M over M is 10 grams per 100 grams of solution. If you see a percentage V over V, the V's mean milliliters because they're volumes. So 12% V over V solution means 12 milliliters per 100 milliliters of solution. And if you see M over V, that's mass to volume, which is grams to milliliters. So a 5% M over V solution is 5 grams per 100 milliliters. And if you see the capital M, that stands for molarity. And so 6.0 M HCl means 6.0 moles of HCl for every liter of solution. So converting your concentration into a conversion factor is critical for this chapter. Let's do a practice problem. How many grams of sodium hydroxide are needed to prepare 75 grams of a 14% M over M NaOH solution? Well, let's start with our given value here. Well, actually, before we do that, let's express this as a fraction, and then we'll use the fraction. So 14%. That is the same thing as 14 over 100. The M means mass, so that's going to be grams. And it's 14 grams of NaOH for every 100 grams of solution. So that's our conversion factor based on the concentration. Now let's start with the given value, 75 grams solution. And this is 14 grams of NaOH per 100 grams of solution. Grams of solution cancels. So we have 75 times 14 divided by 100, 10.5 grams of NaOH. So not terribly difficult, pretty quick and easy math. The hardest part is converting the percentage into a fraction, because you're going to need that fraction to solve your final answer. And 10.5 looks like we did it right. Let's do another practice. How many milliliters of a 5.75% V over V ethanol solution can be prepared from 2.25 milliliters of ethanol? So let's take our concentration and express it as a fraction. This is 5.75 over 100. And because these are V's, that's volume. So we're talking about milliliters. And it's a solution of ethanol. That's our solute, ethanol, and then solution on the bottom. So there's our concentration expressed as a fraction, which we'll need to solve the problem now. So let's start with the given value here. 2.25 milliliters of ethanol. And we're going to use our conversion factor but we need milliliters of ethanol on the bottom if we want it to cancel, which means we're going to have milliliters of solution on top. And so it's 100 milliliters of solution, 5.75 milliliters of ethanol on the bottom. Milliliters of ethanol cancels. And punching it into the calculator, I get 39.1 milliliters of solution. So take your concentration, express it as a fraction, and then use that as your conversion factor to solve the problem. 39.1 looks like we did it right. Do another study check. How many grams of aluminum chloride are needed to prepare 125 milliliters of a 0.150 molar solution? So let's express this concentration as a fraction. So 0.15 capital M means 0.150 moles of AlCl3 per 1 liter of solution. So there's the conversion factor that we'll need for this problem. And the other thing we're going to need is we're going to need the molar mass because they're asking us about grams. So let's go back to the periodic table. So we see that aluminum has a mass of about 27 and chlorine is about 35.5. I'm just rounding to make this quick. So aluminum, we said was 27. And chlorine is 35.5. And there's 3 chlorines. So AlCl3 should have a mass of 133.5 grams per mole. Okay, so those are the 2 pieces of information we're going to need. Now let's set up our equation. So 125 milliliters is our starting amount. Now I'm going to convert this into liters because this is in liters. So there's 1 liter for every 1,000 milliliters. Milliliters cancels. Now we have liter. Now I'm going to plug this conversion factor in right here. 0.15 moles per 1 liter. Liter cancels. Now we have moles. And the last thing I'm going to do is plug this value in. And there are 133.5 grams for every 1 mole. Moles cancels. And we will be left with grams. So 125 times 0.15 times 133.5, all divided by 1,000. And I get about 2.5 grams of aluminum chloride. And it looks like we did it right. So once again, to recap this, there are 4 ways of expressing concentration: mass percentage, volume percentage, mass to volume percentage, and molarity. Mass percentage is grams per 100 grams of solution. Volume is milliliters per 100 milliliters of solution. Mass to volume is grams per milliliter. and molarity is moles per liter. So thanks for watching. We'll see you in the next video.